Good day, everyone, and welcome to today's training session. This is to officially welcome each and every one of you to this very session of our training solar power system installations. This is to welcome each and every one to this very phase of the training session on basic solar power system installations. Like I said earlier, please this is meant to be a live class so that we can be able to interact with each and every one on this platform. And for effective communication, for effective learning, that is why we always advise that if you're in a noisy place, kindly mute yourself so that you do not disrupt the activities of the class. You all are welcome. You all are welcome to the live session um, of virtual text training. Yes. In this live session, in this live class, this is where we are going to be taking our time to walk you through, to teach you, to educate. Mr. Taiwo, can you please mute yourself, sir?
Oh,
Thank you, sir. So this is where we'll take our time to educate each and every one of us on basic system designs, right? Yes, that is what we are going to be doing here right now. From the very beginning, we introduced the course on solar power system, and we made it categorically clear that solar energy is the energy gotten from the sun when one of the solar component in terms of the solar panel absorbs the rays of the sun. It's then converted to electrical energy for us to use in our facility, right? Yes. And we went ahead to say there are two types of solar power system. We have the one we call the on-grid, we have the one we call the off-grid. When you run an on-grid type of solar power system, we are basically trying to tell you or to inform you that you are going to be having access to energy or electricity all day, all time. All right, because you are going to be having solar and you are also going to be connected to any other source of available power supply at that point in time. Then, when you are running an off-grid type of solar system, it simply means you are going to have energy in your facility at specific periods of the day, and which means that you are only going to be running on one power supply source, which is your solar, which is producing energy through your solar panels. We, we also went ahead to introduce the various solar components: the inverter system, the battery system, the solar panel, the solar charge controllers. We had taken our time to break down each and every of these components, right? Yes. We talked about the do's and don'ts. We talked about the basic principles guiding safety rules and regulations guiding your basic system installation. That is very, very correct. Some questions were taken, many answers were also provided on that WhatsApp platform in the last session. So, we are here for a live class. We are here to interact with each and every one on this our very platform. But before we go ahead with tonight's class, before we go ahead with tonight's training, um, we would want to also give opportunity to those who were unable to ask questions, all right, who were unable to ask questions on the WhatsApp platform when the first session, all right, so that if there is anyone who has a question or questions, let that person speak up right now so that we can address it. As long as it is within the framework of what we are doing, we will definitely address it before we proceed into what we have for today. Now, this is the way it is going to be. You are going to be given an opportunity to speak to us, okay? Once you get that green light to speak, what you need to do firstly is to tell us your name and your location, and then you can have your say. You can ask your question. All right, quickly. Is there anyone on the platform right now who has a question or questions to ask from the previous session? You can speak up right now, please. Are you all there? Anyone with a question, a valid question to be asked on this very platform right now before we move ahead from the previous session, before we move ahead? Okay, I guess that silence is an approval for us to move ahead. All right, thank you so much. So, if you can hear me and you are active and you are here with us for tonight's class, please give us a thumbs up. Let us know that you are active. We need to know that you're active here. Let us see your thumbs up or use your favorite emoji. Okay, Mr. Meshach can hear me. Who else? Is it the only one? Uh, Okay, Mr. Taiwo as well. All right. Okay, Mr. Lugbenga too. All right. Thank you so much. Thank you. So we can now start the class properly. Yes. So during the concluding part of the first phase of the training we had previously, some questions arose. Questions such as how are you expected to know the size of inverter system, charge controllers, and any other of the other solar component that will be suitable to power up your facility. And when we saw this question, we tried to answer it to the best of our knowledge. And in order to give you guys valid answers and responses to these questions, we really referred you to something we call energy audit, which simply means that at that point in time, we gave out the response or answer saying that you cannot really directly get to know the sizes of your solar component without you touching or talking about certain things. So it simply means that before you get to know the size of inverter system, solar panel, charge controllers, or even batteries, you need to know what you are powering up. At what point are you powering it up in terms of the length of time it is expected to run. So with that kind of information, you would have to look into what we call energy audit. So, why are we here tonight? We are here tonight to walk every one of us through the process of system designs. And when we say the process of system designs, we are talking about energy audit. And when we say energy audit, we are uh, practically trying to connect the dot between what we are trying to power up with the various sizes of our solar component. So let us take our time to break it down. So energy audit is all about system designs. However, there are levels, there are steps, there are processes, and there are procedures with which you need to go through energy audit. So when we talk about energy audit, we are practically trying to say that you have to firstly know the energy need of a facility by getting the or knowing the information of what you intend to power up. And then using that information of the energy need of a facility in watts to size your various solar components. So it means that if the energy need of a facility is say 1000 watts, you are going to be using 1000 watts to then size your inverter system, use 1000 watts to size your battery depending on the backup time, use 1000 watts to size your charge controllers and also your solar panels. Do not forget your safety tools and gadgets will also be sized accordingly. That is what we are trying to say here right now. All right. I am going to be sharing my screen right now. I am sharing my screen right now. Please, uh, kindly indicate you can see my screen. Can you all see my screen, please? I need you to respond. Can you see my screen? All right, Mr. Taiwo can see it. If you cannot see my screen, then there is a challenge at your end. That is why I keep asking, can you see my screen? You need to respond, please. Okay, Mr. Lugbenga can see it as well. Mr. Passmore, can you see the screen? All right, Mr. Alson can see, Mr. Misha can also see it. All right, thank you so much. Thank you. So we can proceed. So, Mr. Taiwo, what can you see on the screen, please?
Energy audit.
All right,
Uh,
thank you so much. Energy audit, yes. Energy audit it is. All right, thank you. So, just as we were discussing earlier, energy audit is the determination of the energy requirement for a building, just like I was talking about. I gave a brief or a summary of what energy audit is, and what we said was that energy audit is a breakdown of or a connection between 2 points, getting to know the energy need of a facility, which is what you can see on my screen as the energy requirement for a building, and then using that energy requirement for a building to size your various solar components. So on my screen, you can see that the energy audit is the determination of the energy requirement for a building. It is a careful examination of the electrical load. So it simply means that when you are trying to know the energy requirement of a facility or how much energy does a facility consume, you also need to have a good idea of the various loads or appliances that are to be powered up using that your inverter system, using that your entire solar system. So when we say loads, we mean appliances. When we say energy requirement, we mean how much energy are those your appliances going to be drawing from the system when it is installed, and that is in terms of watt. That is what we are talking about here right now. That's what we're talking about here right now. That's what we're talking about here right now. All right. So moving on. So moving on right now. So you could see that energy audit helps prevent oversizing of the system, safeguarding your electrical appliances from damaging from inappropriate power surge, and generally saves you costs. Now we have said on the first hand that energy audit helps you to know the energy requirement for a building, which is an authentic information. This is a follow up to that first information we gave out to also give you further information and things that the energy audit does for you. It is said that energy audit helps you to prevent oversizing of your system, gives you safety and security to that your system, and also saves you costs. We will take it bit by bit, step by step, and then have good knowledge of all of these things we are talking about. Let us start by having a good idea of how energy audit helps prevent oversizing, talk about how it generally saves you cost, and on the long run, we will connect it to the safety and security of your system. I hope we are together on that. I hope everybody is active and can hear me properly. Now, when we say when we say energy audit helps you prevent oversizing of your solar system, it simply tells you that as a professional, at no point in time should you assume the at no point in time should you assume the various sizes of your solar components by merely uh, mm, by, by merely just assumption. Okay, yes, assumption is the right word. So it simply means that you need to do a holistic system design whenever you are invited for a solar project. Doing a holistic system design would help you prevent oversizing or downsizing of your solar system or solar in terms of our solar components. All right. So let's take for instance now. Let's say Mr. Taiwo, who is one of us here in tonight's class, let's say he has invited us to run a, a solar system for him in his facility. And because we do not have good idea of this, he just calls us and said, "Oh, can you guys do this system installation for me?" We said yes. We didn't bother to do any sizing for him. We just asked him, "Okay, what do you want to power up?" He said his TV, his freezer, his AC. We then said, "Okay, no problem. Since you are powering your freezer, your AC, let us give you 20 kVA." Yes, out of 20 kVA, we have quoted 20 kVA. We have quoted the 15 kilowatt hour battery. We have quoted 30 units of 550 watt solar panels. Mr. Taiwo can afford to pay. He got those things and installed for him. Have we done the job we're contracted to do? Yes. But did we do it well as professionals? No. That is where the problem comes in, because as professionals, we were supposed to firstly carry out a holistic energy audit on that facility by firstly getting the complete information of what Mr. Taiwo intends to power up. That is one. And also trying to know the energy being consumed by all of those things. So, and then we'll match it up with the sizes of the various solar components. On the long run, another professional could come into that facility and say, "Okay, oh, Mr. Taiwo, my friend, you have a very good system here. It's a giant system you have here. What size of system is this?" He will say, "Oh, it is 20 kVA installed by VAT Tech." And his friend will be like, "20 kVA, what are you powering up?" He will say one air conditioner with one freezer, one horsepower air conditioner, one freezer, and four lighting points. His friend will just shout, "Oh, those guys are not professionals." Why? Because one AC, one horsepower AC, one freezer with two lighting points shouldn't warrant you having 20 kVA installed for you. So you can see that system has been oversized, it has been overestimated. That is the point we are trying to to point out here right now. Now, how does it generally save you cost? It generally saves you cost due to the fact that when you do a holistic system design, you will be getting the right size, the actual size of system. You'll be getting the actual size of system, you'll be getting the right size of system, and you will not spend more than what you're expected to spend. So if at the end of the day what Mr. Taiwo requires is just 5 kVA system, and we have gone to give him 20 kVA system, you know the cost of 20 kVA system is not the same with that of 5 kVA. At that point in time, Mr. Taiwo has wasted a whole lot of money. Now remember, the key thing of going solar is to also save money. However, we always recognize the fact that going solar is always very expensive in the beginning, but on the long run, it is one of the cheapest power supply sources you can ever think of. So you see the connection between helping you to prevent oversizing of your system and then generally saving you cost. In summary, energy audit links the energy needs of a facility to the sizing of the various solar components required for that system setup. Yes, that is what it uh, typically does. It helps you to link between the energy need and then using that information to size your various solar components. I hope we are still together. I hope we are together. Things to consider during solar energy audit. One, list of electrical appliances to be powered by the solar system. Power rating of the electrical appliances in watt. Daily hours of the appliances. Total energy consumption of the building. So these are the parameters, or these are the things to be considered when you are running a solar energy audit. Hold it strongly at heart. We will come back to it. Importance of a solar energy audit. It provides the data needed for the appropriate system design. It helps identify opportunities to reduce energy use. It helps to reduce the capital costs. It will help to ascertain the backup time of the solar storage. Yes. So that is the part we want to talk about. How does solar energy audit help you to ascertain the backup time of your solar storage? In the course of this study, we are going to be studying what we call the required number of batteries. Now, when we study the required number of batteries, you are going to be relating the backup time of the solar system with the number of batteries required for you to run for that specific length of time. So it simply means in the process of you doing a holistic system design, you are expected, you are required to design a solar system that will run for a specific length of time. So those complaints that the client will tell you that, oh, this system runs only 2 hours and shuts down. This system only runs 1 hour and shut down. This system runs only for 3 hours and shut down would be totally gone. It will be totally removed. You will never have such problems at all in your system design, your system installation. Remember, we have a slogan in this field. An efficient system is a well-designed solar system. An efficient solar system is a well-designed solar system. So when your client tells you this system only runs for 2 hours and shuts down, the first thing you should ask him is, what is the expected length of time he wants it to run? He will say 3 hours. That is one information you have. Then you ask the follow-up question, which is the most important question. What are the things he or she is powering up? That is what will tell you if that battery, if that solar system can as well run for that length of time. Then there's another little secret that you should also know. Yes, which is on the aspect of the battery, on the aspect of the type of battery that the client is using. Okay, because if you consider that little secret or parameter or standard parameter right now, okay, if you consider it, that will also tell you if that battery system can also run for that length of time the client expects it to run. For now, we will not review that secret or that parameter to you. But as we progress, in the training, you will definitely get to know what it is. And we hope you all are available when it is reviewed. I hope you can hear me. Give us your thumbs up if you are there and you are enjoying the lecture. Let us know you can hear us clearly and you're enjoying the lectures. All right, thank you. Thank you. Thank you. All right. Okay. So let us proceed. Thank you so much. Let us proceed. So we know there will be time for questions. We know that there are a lot of questions that might be running through your mind. Calm down, hold on. This is meant to be an interactive session where you get to enjoy the lectures by the trainer and then you ask your own questions. And even the trainer also has the opportunity of asking you a few questions too, to also test that you have also learned one or two things from the lecture. So simply write it down, write those questions down in your writing materials, okay? or you can put it in the chat box here. When it's time for us to take questions, we will take the questions all at once. All right, thank you. So let us talk about safety. Safety as it concerns solar power system. Safety is the act of keeping the entire solar system and your home appliances safe. Yes, it is the act of keeping the entire solar system and your home appliances safe. It is the act of keeping you safe. Now, there have been situations whereby some client has have called and said, "Oh, this system stopped working immediately the thunder struck during the heavy rain." It could be that the rain has damaged that solar system. Some other client will say this inverter tripped off when there was rainfall. Now, one basic thing that could lead to your inverter system misbehaving, tripping, going into deep sleep when you have heavy lightning, not thunderstorm please. It is lightning that is dangerous to your system. It is lightning that is even dangerous to your facility, okay, and not your thunderstorm. Thunderstorm is just an accompanying sound. So it is that lightning strike that is the energy that is being released. Okay, so when that energy is being released and your system is not protected enough, it does not have the right protective devices. Even if it has the right protective devices, it is not those protective devices are not sized the right way. Definitely the system would crash. So when we say even if it has the right, even if it has the the safety tools and gadgets or protective or on it, but they are not sized the right way, there is no protection. It simply means that when you use little children to guard or to form soldiers or military men, you will see that those that security you have gotten wouldn't be as effective as when you use real military men for security purposes. So that is why when you are deploying your safety tools and gadgets, you ensure of certain things. Are they genuine tools? Are they the right tools? Are they the right size of tools? I hope I am communicating. A safe solar system is free from both human and natural disasters or hazards such as fire outbreak, overloading, overvoltage, undervoltage, lightning effect, and shock. Yes. So even some persons go as far as asking, is earthing important in your solar system installations? Yes, it is very, very important. It is as important as you using other safety tools and gadgets. But the question comes, how well do you know how to implement this safety as it concerns your solar power system? That is the question. And if you are able to answer that question, congratulations to you. These are the various safety tools and gadgets you can see on my screen. You have the fuse, you have the breaker, you have the changeover, the automatic changeover or the manual changeover. You have the uh, voltage monitors there. On the screen, you can actually see two different breakers. You have the MCB, you have the MCCBs. Do you know the point you use your MCB? Do you know what point you use your MCCBs? Um, in the last class that we had, someone asked or someone actually made an observation that we didn't talk about the safety tools and gadgets, and we responded by saying yes, that is very correct. We didn't talk about it, one, because we had already put it into the training manual that we have promised to give out to you all. Okay, that is one. Two, for the design of your safety tools and gadgets is not included in this basic course. Okay, which means you have to enroll for the advanced course to get the step. However, for those of you who have enrolled or who will enroll for this basic course, for any project you're having, we will guide you on the selection of your safety tools and gadgets. And that brings me to my next area of discussion. When you are selecting your safety tools and gadgets in terms of the breakers, the fuse, the surge, you should also be aware of the fact that your solar system has two parts. It has the AC part, it has the DC part. Do you know how to identify these various areas? If yes, congratulations to you. If no, this is the right place you have to be. You must ensure that you continue and complete this class, because on no account should you use a DC breaker on your AC side of your solar system. That is the point we are trying to raise here. I hope it is clear. So you have your safety tools and gadgets in this your breaker box or your PV box, as we always call it. So that is what we call it, safety box or PV box. So you have it. You can see the earthing cable. This this yellow and green cable is the earthing cable, which means that the system was properly earthed. All right. We know at this point in time that you might have questions, and like we promised, we will always take questions mid sessions. We will take questions mid session. So we would like to take the first phase of questions. Right now, if you have questions from what we have studied so far, please let it be within the framework of what we have studied so far, please, within what we have studied so far, so that we do not lose focus. You can ask your questions now. Tell us your name and your location, and please ensure you are speaking from a quiet background. If you are not in a quiet background, kindly use the chat box that is available here. Thank you. Okay, are there no question or questions? Should we go ahead? Okay, all right. So everyone is following up. Everyone is following up. All right, all right. Okay, so let's speeding up. Let's move. So we will now talk about the deal of the day. We'll be talking about electrical load analysis. Electrical load analysis. Electrical load analysis is a series of calculations or processes of evaluating the energy needs of a facility. Now remember when we introduced energy audit and we said it helps us to know the energy need of a facility, but uh, we didn't talk about how we are going to achieve knowing the energy need of a facility. Right now, what this electrical load analysis does for us is to help us know the energy need of a facility by walking us through a process, a procedure, and series of calculations. That is what we have to do here. So in summary, electrical load analysis shows the exact energy consumption, wattage of a specific facility. So that is what electrical load analysis is going to be doing for us here right now. We understand the fact that most of us who are having network connectivity issues, okay? We understand that fact that most of us are having network connectivity issues. That shouldn't worry you. That shouldn't discourage you from joining the class. Because this class is being recorded as we are live here right now. It is being recorded as we are live here right now, and it's going to be shared with everyone for free. So after this class, we are going to upload it to our YouTube channel, where you are going to be having access to all the things we have treated today. Okay, we are going to upload it to our YouTube channel for free, where you will all have access to it. So do not worry if you disconnect and you manage to get back on. Kindly continue from where we stopped. Thank you. So, questions asked before carrying out electrical load analysis. At this point in time, it is worthy to inform each and every one of us that before you can carry out any form of electrical load analysis on any facility, there are certain questions you need to ask. There are certain questions you need to ask. Okay. There are two principal questions, and one as a bonus question, altogether making three questions. Okay. You are to ask the energy need of facility. You are to know the backup time of the facility. You are also to find out the budget of the facility. Now, let's take our time to break it down a little bit. So when we talk about uh, electrical load analysis and the questions to be asked, and we say again, assuming Mr. Taiwo is our client for tonight, and he has invited us because he knows our professional our professionalism in the field. We are professionals in the field, and then he has asked us to come and run a solar system for him in his facility. So on getting there, the very first question we're to ask our client, Mr. Taiwo, would be, what is his energy need? So if Mr. Taiwo is a new person to this field, what is expected to respond would be that he doesn't have idea of what we're talking about. And then we can break it down for him. We can break it down for him by telling him to give us a list of the various appliances he intends to power up using the solar system. Now, at that point in time, he can now say he wants to power up his TV, he wants to power up his freezer, he wants to power up his laptop, his bulbs, and whatever he intends to power up. Those are the things we are going to be working with. Then we will move ahead to ask the second question, backup time of the solar system. So this backup time is in hours, all right? And what this backup time is trying to tell us is that it's going to be giving us the information of how long Mr. Taiwo wants this solar system to run in the absence of solar or any other source of power supply. So it means that when there is no solar energy or energy being generated from the solar panels, when it's no longer coming, how long would the energy stored in the battery system run for, Mr. Taiwo? That is what that backup time simply means. So it is in hours, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 10 hours. The higher the backup time, the higher the cost of installation. Then we move ahead to talk about the third parameter there by asking our client the budget. Now, why this is included is to sound it very clearly that it is also very important, because oftentimes most of our trainees have found it uh, challenging to ask this kind of question. Yes, they have found it very challenging to ask this kind of question, to ask the client his budget, how much he has for that project. Now, why are we making it compulsory? Is due to the fact that some clients will have good taste. Some clients will have large energy need while they have little amount of money to execute it. So if you have seen if you have met a kind of client who has a hunger for a large energy need, and you feel, oh, this is something you need to ask this man, please go ahead and ask. There is no harm in asking. Once again, there is no harm in asking. Ask the client, please, sir, what is your budget for this project? And from the response, you can now easily know if it is uh, good for you to proceed or take a break. Yes, that is the right thing to do. That is the right thing to do. So, in most cases, when the budget available cannot be able to execute the um, design system, what do? You opt for what that budget can execute, and then you advise the client on how to run the system. That is the best you can offer to that client at that point in time. I hope we are all following. I hope we are all following. Importance of electrical load analysis. Thank you so much, Mr. Taiwo. Thank you, Mr. Delkin. If I murder your name, please pardon me. We are all African brothers. However, yes, Mr. Darkin, we are all African brothers. However, because of the tongue issue, we might not be able to pronounce your names well. Thank you, Mr. Oluwagbenga. All right. So, importance of electrical load analysis. It ensures proper sizing of system. It prevents overloading. It prevents fire hazards. It improves safety and efficiency of your solar system. That is very correct. Now, this is the critical moment we have been waiting for. This is the point. This is where we have been firing to get to. This is the question that most persons have always asked. Electrical load analysis table. Electrical load analysis table. So on my screen right now is a typical example of an electrical load analysis table. This electrical load analysis table is what really helps you to actually know the energy need of a facility. This um, this electrical load analysis table is what you use to collect raw data from your client facility. Then that data you have collected, you then convert it to what do you call it now? The energy need of the facility. Then from that data, you also do a holistic and complete system design for the inverter, battery, solar panel, solar charge controllers, cable, and your various uh, solar safety tools and gadgets. On this table, it has incomplete data or information on it. As you can see, where you have the question marks, where you have those question marks means that there are things that are expected to be there. There are parameters that are expected to be there, which would help us carry out a load analysis on this table. Okay, but then they are not there, they are missing. So let us go firstly talk about those parameters before we then come back to the table to know how to apply the load analysis. So parameters for electrical load analysis. These are parameters, these are those missing items on that table. Quantity of appliance, power consumed by an appliance, the running time of an appliance. So these are standard parameters which will aid you, which will help you to be able to carry out a holistic energy audit in terms of load analysis, electrical load analysis on this facility. Let's take them one after the other. Quantity of appliance typically tells you the exact amount of appliances that of the same appliance that Mr. Taiwo intends to power up using the solar system. Let's take, for instance, Mr. Taiwo lives in a three-bedroom apartment, and in each of those rooms he has a television in them, all right? And for this specific installation we want to do for Mr. Taiwo, he wants to power two TVs in that his house. Out of four, he wants to power two, one in the living room, so that whenever he comes back from work in the evening, he can listen to politics today, know what is happening in Nigeria, okay, and stay ahead in current affairs. And because of that, the children might also want to watch cartoon. And so he's considering, okay, there's a television in the children's room. We should also be able to power it up at the same time, so that when he's watching his news in the sitting room with one of the TVs, the children will not disturb him because they will also be busy watching the cartoon in their room. So it means on our table of load analysis, we are going to be considering two televisions to be powered up. These two televisions are going to be of the same type. They are going to be the same. They are going to have the same parameters as well. I hope that is understood. Power consumed by an appliance. Power consumed by an appliance. The power consumed by an appliance typically tells you the rated wattages of each and every appliance that is to be powered up using the solar system. Okay, that is the power consumed by an appliance. It tells you or gives you the information of the rated wattages of each and every appliance. Now the big question is, how do you get to know the rated wattages of each and every appliance? It is usually gotten from the nameplate of each and every appliance. It is gotten from the nameplate of each and every appliance. The nameplate is that position on the body of your appliance or packaging, which is a carton, which contains so many details such as the name of the product, the maker of the product, the serial number of the product, IME number of the product, current, voltage, frequency, wattage, any other information, even safety precaution and the rest of them. They can also be on that nameplate, depending on how big or how small the nameplate is. For this class, I have a typical example of an LG nameplate. Okay, LG television nameplate. Now, this is a little task for everyone in this class. Okay, this is a task for everyone in this class. I want somebody in this class, the first person in this class, or anybody who can actually tell us the power consumed by this LG TV. What is the power consumed by this LG TV looking at the nameplate? Can anyone see it clearly?
195 watts.
Thank you, Mr. Taiwo. 195 watts. Our client is very active. Are you sure we can be able to get money from this our client, because he's very very active and he knows what we are doing here? Thank you so much. Thank you so much for that, Mr. Taiwo. So it is good that even as a client, you also have good idea of what you're working on. So it will help you to stay ahead of the installers, even though the installers will still play tricks and do their thing. Yes. However, you must have good knowledge of what you intend to do. Yes. So it is 195 watts for this LG um, TV. Running time of the appliance. Running time of the appliance typically tells you the specific length of time the client intends to power up those television or to run those appliances or loads. So this running time only takes effect when the appliances are turned on. That is only when it takes effect. When the appliances are turned on. All right. So we are back to our electrical load analysis table. We are back to our electrical load analysis table. Once again, before we proceed to the final stage, which is now the complete design stage for us to know the uh, energy being consumed by these appliances, we want to take a break again. We want to take a pause again here while we are looking at this table. If we have questions from what we have studied so far, we can actually take those questions right now. If there are questions from what we have studied so far, so good. Let us pick up right now, please. Are there any question or questions, or should we go ahead? Kindly give us your favorite emoji. If you are here, you are active, and you are enjoying the lectures. Give us your favorite emoji. Thank you, Mr. Delekin. Thank you, Mr. Luagbenga. Thank you, Mr. Meshek. Thank you, Mr. Andre. All right. Okay. So I think we can proceed. Everyone is good to go. So back to this our table which we saw initially from the very beginning. You can see the table is all complete now with the various information that was missing. So it has quantity of appliance, power consumed by the appliance, and the running time of the appliance. So let's say again, our client Mr. Taiwo has invited us to run a solar system for him in his facility. And then we have asked him that very first question we we said we would ask. Can anyone remind us the first question we had to ask when we are invited for any solar project? Can anyone remind us?
Energy needs.
Thank you, sir. Energy
Yeah.
need of the facility. So we have asked Mr. Taiwo what is the energy need of this his facility, and he has now told us he wants to power up these five appliances. These five appliances: DVD player, light bulb, ceiling fan, refrigerator, and a blender. Yes. So these are the five basic appliances he wants to power up. And then we are to work on it as professionals to firstly know the energy need and then use that information to size the various solar components before we go for procurement and then the installation as the final stage. Right? Yes. So how then do we run electrical load analysis on this facility? There is a method we will use, there's a formula we are going to use. Okay, so that formula states that what energy consumed is equal to energy consumed is equal to quantity of appliance multiplied by the power consumed multiplied by the running time. Quantity of appliance multiplied by the power consumed multiplied by the running time. And how do we apply that formula? There's a technique to apply it. We will use the we will apply the energy consumed by each of these appliances. That is to say, get the energy consumed by uh, DVD player, light bulb, ceiling fan, refrigerator, blender. And at the end of the day, we add all the various energy consumptions up. Once we do, that becomes the total energy consumption, which also translates to the total energy need of the facility. I hope that is very clear. I hope everyone is understanding what we are talking about here right now. So,
Sorry, can we go over that just the last issue, just immediately the last issue again, please? Sorry.
the,
The quantity by energy consumed by running time.
okay,
Can we quickly sorry.
okay, just as you can see on my screen now, sir, I said Okay, the formula is energy consumed is given as quantity of appliance multiplied by the power consumed multiplied by the running time. And the way you are expected to apply that formula is you get the energy consumed by each of these appliances. That is to say, get the energy consumed by the DVD player, get the energy consumed by the light bulb, get the energy consumed by the ceiling fan, get the energy consumed by the refrigerator, get the energy consumed by the blender, and then you sum it up. That is to say, you add everything up all together to give you the total energy consumption, and that becomes the energy need of the facility. Mr. Taiwo, are we together now, sir? Thank you so much. So let us now quickly do the design. For the DVD player, 3 multiplied by 100 by 1 gives you 300 watt hour. For the light bulb, 1 multiplied by 100 by 2 gives you 200 watt hour. For the ceiling fan, 10 multiplied by 10 by 24 gives you 2400 watt hour. Refrigerator, 3 multiplied by 10 by 4 gives you 120 watt hour. For the blender, 1 multiplied by 80 by 1 gives you 80 watt hour. Then you have a total of 300 plus 200 plus 2400 plus 120 plus 80, which will give us a total of 3100 watt hour. And then you can now see on our table of load analysis, electrical load analysis table, that we have a total of 3100 watt hour, and that becomes the energy need of Mr. Taiwo's facility. All right, questions, please. Let us now have questions for the night. Talk to us, sir.
Yes, sorry, I'm going to because this is really the issue. This last aspect we are talking about, the end calculation of energy needs. So, can we quickly just run back just a little to work on that energy need again? Sorry to disturb. Yeah, because this is the cocoa of this whole thing. Because once we don't have the energy needs, the design will be faulty. I guess. Thank
Okay,
you.
okay, so we'll do it one more time, sir. We'll do it one more time for the sake that you are our client for tonight. So, now, the explanation is this. The explanation is this. We have a formula which we use for or to get the energy need of a facility, right? Yes, we have a formula for that, which says that uh, energy consumed is equal to quantity of appliance multiplied by the power consumed multiplied by running time. Even if you are writing, I don't think you need to disturb yourself with that, because it is also available in the training manual. Okay, so you might not need to worry yourself so much, and we're also going to make this video available for everyone. So energy consumed is given as quantity of appliance multiplied by the power consumed multiplied by the running time. All right, let us be clear on that formula, because that is the basis or the foundation of everything we are to do here. So, and the method or technique I said we will use is we are going to apply that formula on each of these appliances to know their various energy consumptions, and then to get the total energy consumption by adding them up, which will also translate to the energy need of the facility. And that is what we have just done by getting the energy consumed by the DVD player to be 300 watt hour, energy consumed by the light bulb to be 200 watt hour, energy consumed by the ceiling fan to be 2400 watt hour, energy consumed by the refrigerator to be 120 watt hour, energy consumed by the blender to be 80 watt hour. And if we add everything up, it is going to be giving you 3100 watt hour. That is how we arrived at this answer on this table that you can see here right now. All right. I hope we are good right now. Questions now, please.
All right. So it means the answer that you have get, it will help us to know the system that we use, isn't it?
That is very correct, sir. Thank you. Any other
Okay,
question?
if I may.
Yes, go ahead, please.
Okay, you forget the aspect of energy loss and other other aspects. Like during protection, we do lose some energy. Does it include during calculation of energy need?
I am not getting that. Can you rephrase your question? That reminds me, you didn't tell us your name and where you are speaking from, please, before you even
Okay,
ask.
okay. I'm sorry for that. I mentioned from Kenya.
Okay. Go ahead, sir, with your question, please.
I'm asking the aspect of energy loss you didn't include on the total calculation of the energy need.
No, for energy losses, you don't need to include it in your energy need. You don't need to include
Okay,
it
for
in your.
example, I've given that a client, that's the energy need. The client may go with that information and purchase exactly battery size and solar panel from the seller when I'm not there. Maybe I'm just giving him a quotation to go and purchase from my analysis. How will I sort that?
Hello, sir. Can you finish your question, sir?
Yes, I was saying
Mm-hmm.
we have finished calculation of the energy need.
That's
Is
correct.
it right?
Yes, that's correct.
Yeah. Then you would you tell a client that in this building we'll need like a 4 kVA,
Mm-hmm.
a 4 a battery. Then clients, from what you said, you just call you another day and say, "Oh, my friend, come and install these things. I've already bought them." Without doing consultation to you, without doing anything after you are done with calculation. But the aspect is still there. You have not finished the whole procedure because there is energy loss for each appliances. There's energy loss.
Okay,
Are you
so
getting me?
no, I'm not getting the aspect of including energy loss for each of the appliances. Um, if you are worried about um, if you are worried about equating the energy need we have designed with the purchase of the size of the inverter system, and you are worried that the client might buy a wrong inverter system or a system that will break down along the line, is a different thing entirely, sir.
Okay.
Yes, it's a different thing
Oh,
entirely,
am I ahead or I'm still back?
sir.
I'm saying, I'm asking if I'm going too far or still hold on.
No, no, no. And you're not going too far and you're not going too slow. It's just that the questions you are asking are not right at this point in time. So they are not really coming together, okay? Because what you're expected to ask is, how do you know? Because your question is, how do you know that what your client has gotten is the exact thing that you need when you have not finished the design? That's your question, right?
Yeah, yeah, yeah. Because
Good.
some may he may tell you, I have this, and that. Mathematically, in your off head, you may say, oh, this is what you need. Actually, you may need something like a 10 kVA kilowatts. Yet,
Good.
there's another kilos and whatever and whatever.
Okay, then good. If there is your worry, then you don't need to talk about energy losses, because when you talk about energy losses, are you saying that the sizes of those appliances are not the actual sizes, or are you saying that those appliances or loads are going to be losing energy? Is that what you're saying? I don't think that is correct at that point in time. That's why I said it is a good question, it's a good consideration, but not at that point in time. So when you consider energy losses is when you are sizing your solar cables, which is a different ball game entirely. Okay. So what you are supposed to do now right now is you know your energy need of the facility, which you are expected to then use to size your various solar components, starting with the inverter system, right? So your worry now should be when, since you have not finished sizing the inverter system, the client goes to buy the inverter. Your worry should be, how do you get to know that this system will not break down? And that is the answer we'll be giving to you right now. There is a parameter called tolerance, which you need to put into consideration when you are sizing your inverter system. Okay. Already, it is worthy to note that um when you have gotten your energy need, you can easily know the size of inverter system to get. That is very correct. But for the sake of the client adding more loads in the future, you need to make provision for those things that will be added in the future, so that the client will not call you back and say, "Oh, Mr. Mishek, this system you installed has broken down." You need to be very sure that that system was properly designed. But we are not there yet. When we get there, we hope you are in that class when we are sizing the inverter system. You see how all of these things play out, sir. But for energy losses, that is not correct at this point in time, sir.
Okay, thank you.
You're welcome. All right, Mr. Dennis, go ahead with your question, sir.
Okay, good evening, sir. My name is Dennis Basi from Akwa Ibom State. Now, you made mention of summoning the courage to, ask our clients his budget for the work. Now, won't, in order to maneuver, probably just, I don't know, in a situation where our client's budget is lower than the exact amount we're supposed to do the work, probably do a good work for him, but he has something lower. Hope trying to maneuver, getting some materials to get the work won't affect our integrity in the long run, probably getting a substandard material for the work. On that, or how do we go about that? Probably in a situation where we were given low budget compared to the actual amount of budget, then we still want to do the work for the sake of working and not lose the job. How do we maneuver so that it does not affect our integrity in the future and probably recommendation? Thank you.
All right. Okay. So that question is also a very good question. How do you handle such situation when the available budget isn't enough or wouldn't be enough to execute the original system design? How do you maneuver? That is the right word. Do you go for ingenuine or fake product? No, please. One of the basic or one of the major causes of solar system failures, solar system fire outbreaks, is using fake or bad products to work. So please, at all time, avoid using ingenuine product. That is settled on one hand. Now, how do you do these things? The truth remains that for every budget available, there is always a right system for it. Yes, for every budget available, there is always a right system for it. Let's take, for instance, the client has a budget of 150K, 150,000 naira. Okay, let's use a single a currency that everyone is familiar with. Let's say 10 USD. Okay, no matter the country you're from, you know how much 10 USD is worth in your currency. So let's say 10 USD is what the client has, 10 US dollars. But then what you have designed is for $50, right? Yes. And I've made an initial statement saying that there is always a right system for every budget available. But then the question is that what the client might want to go for? No. For your $10 that is available, might just be able to purchase your inverter system. Yes, for your $10 that's available, might just be able to purchase your battery system, your lithium battery system. Fine. Now, what do you do at that point in time? What you would do as a professional is to calmly advise your client, sir, this your budget you have cannot be able to execute this project. However, we can give you an option for which this your budget can execute. Okay, we will give you a complete system which your budget can easily execute. However, the problem will be, or the challenge will be, that your initial plan or energy need will not be met, which means you cannot power up all the loads at the same time. That is a consequence. Okay, or you might not even be able to power some of the loads. Let's take for instance, if the initial system design is 5 kVA and you cut it down to 2.5 kVA, your 2.5 kVA might not be able to run your 2.5 horsepower uh, air conditioner with your freezer. So which means one of them have to go for the other to be active on that system. Yes. So when you do these things, you remove some things, you introduce load shedding. When you're not using some appliances, you turn it off to turn on the other ones. That system can work at that point in time. Then you also introduce your client to what we call system upgrade, solar system upgrade. One good thing about your solar system is that every part of it can be upgraded. Every part of it can be upgraded, which simply means that you can either change, you can add to it, or even do total replacement. So if it is the inverter system that was small initially, on the long run, you can get a higher size inverter system, replace the old one that is there, sell the old one, get more money to buy another one, or get a new inverter, join it with the old one, that is combine them, you synchronize them or you parallel them or you loop them, whichever one you are comfortable with. It will work as a single unit. That way you have upgraded that system can power up more loads. If it is the issue of solar panel, you can add more solar panels so as to generate more energy, so as to generate more charging current, so as to charge your batteries faster. If it is the issue of backup, you can get more batteries and add to it. So that is the way, and the more professional way you can handle these things. Mr. Dennis, I hope we are together on that. Are you still here, Mr. Dennis? Okay, I think he's having network issues. Okay, go ahead, Mr. Andre. We saw your hand up earlier. Mr. Andre, are you there? Your hand was up earlier. Talk to us.
Yes, I'm here. My name is Crispinus. I'm from Kenya.
Okay, talk to us, sir.
But yes, my question has already been answered. The
Oh,
time you were answering for the Mexican and Dennis, I got the answer.
all right, all right, all right. That is great. That is great. Okay, I think
Thank
there's another person who raised up a hand to ask a question. Are you still here? I think we can take one or two more questions. Our client, Mr. Taiwo, I hope we have been able to do a good job for you.
Yes, I'm here with you. I'm listening. I hope I won't be jumping the gun here. We the last energy audit we did is 3,100. I think that's watt hour, or is it kilowatt hour?
It's what hours.
So watt hour. Sorry. So and sorry, most lithium batteries I see around, they say 5 kilowatt hour, 5 watt hour. I think it's kilowatt hour. I always say 5 kilowatt hour, 15 kilowatt hour, 18 kilowatt, something like that. So I'm trying to, in my head, I'm trying to marry the two. 3,100. Then we are talking of 5 kilowatt hour. I don't know. I hope I'm not jumping the gun. Are we supposed to address that now? Or we will get there?
Okay, so the question we have for you is, before marrying them, did you pay the right dowry for them? All right, sir. So um for this your energy need and your sizes of your lithium batteries, which are rated in kilowatt this is not the time to bring them together to have an understanding of them. Okay, a time will come you will get to understand it. Okay, if I may ask, why are you trying to bring them together, sir? Let's see if we can actually give you an answer to what you are asking.
No, I'm just, it's just I'm a little confused. You understand? Because when we calculated the energy need now,
uh,
we are 3,100 watt hour. So
uh,
I was just thinking in my head. Actually, I was just thinking in my head. Okay, how does 3,100 watt hour, then how does it relate to 5 kilowatt hour of lithium battery? You know, so it was
yes,
just
sir.
something, man. That was why I asked that. I hope I'm not jumping the gun. If I am, then I will just wait till we get there. You understand? But it was just something in my head that how does because I was just trying to, as you said, marry the two, and they were not compatible. But I'm sure there is the way we get there, we will we will look into it.
Okay, sir.
Thank you. Yes,
All
sir.
right.
That's right. Yeah.
All right,
All
sir.
right.
All right, so I understand that. Okay, so we definitely get them. We definitely get there. I like your curiosity, sir. You want to know more, and that is a very good. So let me give you something to go home with, so that you can actually do more digging and more research, so that when we come for the next class or when we are ready for it, you have more questions to ask. You can actually bring your energy need and your size of battery together. If you're talking about your lithium battery now, which is rated in kilowatt hour, okay, the only time that can happen is when you are trying to know the backup time for that system. That is the much we can give to you here right now, sir. Okay, and we would also point you to a direction. We'll point you to a direction, sir. We have a complete tutorial video on our YouTube channel, which is I think is titled the lithium battery versus lead acid battery. That is a good tutorial video for you to watch, sir. Another one is assignment on inverters. Okay, yes, assignment on inverters. Yes, that's another tutorial video you should also watch. They are both very good, and we point you to a direction and give you good answers to what you are asking about. And then when we now come for the class officially, we will give you all and the complete information, sir. Thank you so much. All right, I think we can take one more question before we call it a day. We can take just one more question. Just one more question. I believe a lot of persons have network connectivity issues. Like I said, this class is being recorded and will be shared with everyone. Will be shared with everyone. It's going to be uploaded to our YouTube channel so everyone can have access to it. All right. So, if there are no other questions, we believe that we have done justice to this or to today's lectures. And that is to tell you that this is the end of the session, and we are telling you to enroll for the premium class in order to continue and complete the training course. Yes. So at this point in time, what it simply means is that the 2 days free training we promised has now officially come to an end. Yes, I will take it again. The 2 days free training we promised has officially come to an end. And that simply means that you need to pay in order to continue and complete the class. So If you have not paid at this time, you need to hasten up and pay. And if you have paid already before the class started, congratulations to you, because you are going to have unrestricted access to information. All right, that is what is going to happen right now. You are going to have unrestricted access to information. For Nigerians, you are paying 5,000 naira. For Liberians, 12 USD. Zimbabweans, 12 USD. Ghanaians are paying 300 Ghana cedis. Cameroonians 8,500 CFA. Please, Cameroonian CFA, please. If you are here, you have not heard your payment method or the amount you have to pay, you can as well let us know. It is a one-time payment, please. It's a one-time payment of which if you pay once, that is all for the day. You don't have to pay again. And it covers the training material, which is the training manual and these live classes. You also get mentorship attached to it, and you continue to learn on our platform. All right, general questions right now as we wrap up for the day, please. Any questions right now on the payment, please? Questions concerning the payment right now, please. Questions concerning the payment right now, please. Are we still here? Can you all still hear me? Kindly give us your favorite emoji if you are still here and you can hear me. All right. Thank you so much. All right. Okay. In the absence of no other question or questions, this is where we shall call it a day for tonight's training. And we hope to see you all in the next training session, which is tomorrow. Same time tomorrow is also going to be a live class like this. It is also going to be a live class like this very one. We are also going to enjoy it like this. All right. Make your payment, make your payment, and then send in the evidence of payment for confirmation. And once we confirm it, you will be added to the class. Please note that once you pay and you confirm it, you are going to be added to a different class entirely. So don't expect to get the link of tomorrow's class on today's on this general group. No, you are going to be getting it in the premium class group where you all are going to be added. Thank you, thank you, thank you. Have a wonderful night rest, everyone. Bye bye. Thank you so much. Thank you. Thank you.
Meanwhile, I've exhausted my money. Oh, don't make me the client tomorrow.
All right, Mr. Tyro. Don't be too scared, sir.
It's all right.
All right,
Good
sir.
night.
Yeah, good
Yeah.
night, sir. Good night, sir.